With this video, we're going to share one of our test and measurement solutions for the automotive industry. One of the unique attributes of this system is the non-contact inspection technology used for verifying a 60-pin header assembly. This part is a 60-pin PCB to wire header connector, and it is used in the automotive applications where a printed circuit board connection is needed to a wire harness. Let's break down the system requirements in a little more detail. So the requirements for the system were first to clean the part from foreign debris, then verify the electrical integrity of the part, measure pin height and position, laser mark with a 2D barcode and verify the barcode, package parts in trays, or reject failed parts. Let's walk through each one of these requirements. So material handling was one of the big requirements. There is a fast cycle time required for the system, around 4 seconds. We had to remove the part from an incoming pallet that's used upstream in the manufacturing process of the part, and then take the part off of that pallet and index it through the machine at a takt time of 4 seconds. Next was an electrical test that had to be performed on the part. A continuity test was first performed on the pins to make sure we had electrical continuity from end to end, and then a high pot test is performed to make sure that we have integrity between the pins, where we have isolation between the pins. Non-contact measurement was a big part of the system. We wanted to make sure that we were able to measure the pin height and pin locations. There was a challenge of a large field of view for the cycle time that we had, as well as false reflections that were presented from the part due to the reflective nature of the pin material. And then third was to create a datum reference so that all measurements can be measured back to that datum. In addition, we had to package the part, so as parts were produced and they passed, we had to put them in trays that were used to ship to their end customer. The customer also wanted that we had unintended operations, so we provided input and output cues for the system so that the system can operate unattended for 60 minutes. Last was the fast cycle time required for the system. This required us to break some of the inspection functions into multiple stations, so that we're able to scan a smaller field of view within the required cycle time and have the ability to process that data in real time and still maintain our cycle time. Let's review some videos of the system in operation. First is material handling, which you see now is the pallets coming into the system, where they enter into the system and they are stopped at the input location for our system. We will pick the part off of the pallet, and then the pallet gets recycled back upstream. The part will be indexed into the first station, which is the golden sample scanner. The scanner will scan a barcode on the part, and if it is a golden sample, it will switch the system operation into golden sample mode. This mode allows the system to test known defects and determine that the system is catching those defects. This allows the customer to introduce these golden samples on a periodic basis to the manufacturing process and make sure the system is identifying defects as needed. Once it moves from the golden sample station, it will index to the cleaning station. This is where pulsating air is applied to the part and foreign debris is removed from the connector. Once it moves from cleaning into the next station, which is electrical test, this is where the continuity is performed on the 120 pin connections, verifying we have continuity from end to end, and then a high pot test is performed, making sure we have isolation from pin to pin on all the different connections. The non-contact measurement is broken up into several stations so that we can scan a smaller field of view. We have several scanners that will scan both the board side of the connector as well as the mate side of the connector. On the mate side, we've broken out into each 30-pin pocket versus scanning the whole connector at once. The multiple sensor approach and multiple station approach allows us to be able to acquire the data and process the data within the desired takt time for the machine. An example of what the data looks like and how it's presented to the operator is on the screen now. It shows the board side and mate side measurements, where you can see the position as well as height Green would indicate that the measurement was successful and it passed, and red would indicate that the measurement failed. All the data that's collected is stored in a SQL database, so it can be retrieved later for processing and analysis based on barcode, date code retrieval method. The next station after the inspection is laser marking. This is where a 2D barcode is applied to the part if it had passed all the functions in the previous stations. If it had failed, it would get a unique identifier for the failed station so that they can review that part and determine what exactly failed on the part. A barcode verification is performed after laser mark to make sure that the laser mark was applied correctly and it's oriented correctly. Once the part has completed successfully all tests, it will be moved to the packaging location. If it had failed any of the tests, it would be moved to a reject location where the customer can look at the parts and determine if they have a systemic failure or it's just a one-time failure. Once the part moves to the packaging location, it will be pick and placed into trays that are indexed through the pick and place location. The system was designed to have an input queue and output queue so it can operate unattended for up to 60 minutes. We provided safe zones in the machine to allow empty trays to be loaded while the machine is operating, as well as a safe zone for the output loaded trays so that they can be removed while the system is operating as well. Conveyor system in between will index trays between the input and output locations so that the system can operate while those loading and unloading operations occur. The system cycle time was one of the bigger challenges, and in order to achieve that, we had to separate and stretch the machine. So we separated functions to each station, and then we stretched one of the longer cycle time requirements, which would be the scanning, and we broke that into multiple stations to give us the ability to achieve attack time. We also created a parallel processing model for the data so that we were able to acquire information from multiple scanners in parallel and process that data in parallel, all helping us achieve the 4-second cycle time. So in summary, we created a system that would take a part off of a pallet created by our customer and return that pallet once the part's taken off. We integrated a cleaning station where we would remove foreign debris from the part, electrical tests, performing continuity and high-pot, inspection station to handle the true position and the pin height measurement requirement, laser marking station where we apply a barcode and verification, a reject conveyor where parts, if they did not pass, would be placed, and then integrated packaging so that we can package the parts in trays and have about 60 minutes of unattended operation. If you'd like any further information, please visit our website at g2tech.com or email us at sales@g2tech.com.